Okay, all right. So we want to continue with our series of teaching on the chemistry jam syllabus, and today we are going to be looking at another topic. The topic is titled "Rate of Chemical Reaction." Rate of chemical reaction. That's our topic of discuss for today, rate of chemical reaction. Okay. I still remain your teacher and John Femi Excel, and I'll be taking you through rate of chemical reaction. So let's look at our learning objectives for this particular topic. It is expected that by the end of this lesson, students should be able to define the rate of a chemical reaction, describe methods used to measure reaction rates, and identify factors that affects the rate of a chemical reaction, explain the collision theory and activation energy concept. Okay, interpret and draw reaction rate graphs, and also apply knowledge of real life example and industrial processes. So these are the things that we are going to be covering, and it's expected that you should have a good grasp of these these things as we move along in this teaching. So that so I've shared the learning objective, so we can jump quickly into the body or the nitty-gritty of the lesson now. Okay, so let's go into the topic proper and start off with an introduction to rate of reaction. We will define, so we are going to be defining rate of chemical reaction to be it refers to how fast reactants are converted to products. So it is all about how do we get reactants from just being reactant to the product side. So the rate of chemical reaction refers to how fast reactants are converted to product. It measures the change in concentration of reactants or products per unit time. So the rate of reaction measures the change in concentration of reactants or products per unit time. Okay. Okay. All right. So we look at this simply. The rate of reaction is the change in concentration of reactants or products per unit time, just like it is succinctly displayed with the diagram there. So that is what rate of reaction is, change in concentration of reactant or products per unit time. Okay, so the formula basically is rate equals to change in concentration divided by the time that is taken. So that's the formula that we use to calculate the rate of reaction. Okay. We must also be able to know that there are reactions that we call fast reactions, and there are some that are slow reactions. Fast reaction basically includes explosion, combustion. These are fast reactions that take place spontaneously and suddenly. And there's slow reaction like rusting, food decay. They take place gradually over time. It is not spontaneous. It's not something that happens suddenly, but it takes time. So those are they're referred to as slow reaction. Okay. So what are the methods of measuring reaction rates? Several methods can be used depending on the nature of the reaction. So we can have measuring volume of gas produced, e.g., using a gas syringe or inverted measuring cylinder. So this is one method of measuring reaction rates. We can equally make use of monitoring mass loss if gas escape from the reaction vessel, so we can monitor mass that is lost. Okay. Thirdly, we can by observing color change or formation of precipitate, e.g. thiosulfate plus acid reaction. So we can also measure reaction rate by observing color change or formation of precipitate. Okay. All right, so we can also use pH change in acid and base reaction as a yardstick to measure reaction rates, especially in acid-base reaction. So the choice of methods depends on the type of reaction and products that is formed. So this is what determines the methods that will be adopted, to measure reaction rates. Okay. So the setup looks like this. So we can have, something like this method of gas collection using a gas syringe. So we have that, and then you have a graph of typical results is shown below, where you have your fastest starts, then you have reactions slowing down, then you have reactions stopped, so that's that for that. Okay. Let's move along now and look at factors affecting the rate of reaction. What are the factors that affect the rate of reaction? Number one is several factors can influence how fast the reaction proceeds. So several factors can actually influence how fast a reaction proceeds. So what are the factors affecting the rate of chemical reaction? Number one, concentration of reactants affects the rate of reaction. So if you have a reactant that is highly concentrated, it may also impact on the rate of the reaction. So higher concentration means more particles in a given volume, more collision, and faster reaction. So when you have a higher concentration, it means that more particles are released in a given volume, and then more collision and faster reaction is observed. So let's so we must be mindful of that. So concentration is the first factor. The second one is temperature. Temperature is also affect the rate of reaction. And we said increasing temperature increases particle energy. More collision with sufficient energy. So when you increase temperature, you increase the particle energy. So this results in more collision with sufficient energy. So temperature is another factor that affects the rate of chemical reaction. So we also have surface area as another factor. The smaller, particle size, more surface area, the faster reaction because more particles are exposed. So when you have a substance like that is in the powder form and a substance that is not in a powdered form but in a semi-solid form, or that is even in a solid form, we discovered that, the one in the powdered form will the rate of reaction will be higher. And the reason is because of what? It has more surface, for reaction to take place. So the surface area is another factor that affects the rate of reaction. Then catalyst is another factor. Substances that lower activation energy, speeding up reaction without being used. Without being used up. So that's what a catalyst is. So it also affects the rate of chemical reaction. Pressure, for gases also affects the nature of policies of um, pressure also, especially for gases, also affects the rate of reaction. So when we increase pressure, it compresses the gas molecule, then more frequent collision is observed, So pressure is another one that affects or impacts upon the rate of reaction. So let's take note of that. So each factors affect the frequency and of energy particle collisions, and that is what they do basically. Okay. Righty, so that's that for that. So let's look at the collision theory now. The collision theory. The collision theory states that for a reaction to occur, One, reactant particles must collide. If they don't collide, the reaction will never occur because it's their collision that leads to, the occurrence of what's it called? Um, that leads to, product formation and so on and so forth. So the collision theory said that for a reaction to occur, reactant particles must collide. Number two says collision must occur with enough energy to overcome the activation energy barrier. Okay, so that's number two. The third one is that proper orientation during collision is necessary. It's very, very necessary. And then we say that more frequent effective collision equals to what? Faster reaction rate. Okay, so we look at it now. Low concentration, few collision, high concentration, more collision, just like we depicted in with that diagram. Okay, so we want to look at activation energy now, and we define activation energy as the minimum energy required for particles to successfully react upon collision. So the minimum energy required for particles to successfully react upon collision. So that's the activation energy for you there. At higher temperature, a greater proportion of particles possess enough energy to overcome the the activation barrier. So we say at higher temperature, a higher proportion of particles possess enough energy to overcome the activation barriers. So catalysts lower the activation energy, providing an alternative reaction pathway. Okay, so we have something like that. You have the reactants, then you have the products. Hmm. Yes, so that's how it looks like. So we can see where the activation energy is. So let's take note. Okay, so all right. So interpreting reaction rate graphs, we need to know how to interpret reaction rate graph. Okay. Just a minute, I'm coming. Trying to see something. Just checking. Okay. All right. Sorry. Okay. I think I'll have to continue from there. Um, okay. Just want to be sure. Okay. But I think I was mixing it up. Okay. All right. I'm back now. So, interpreting reaction rate graph. Reaction rates can be visually represented with graphs. And if you look at it, this is a reaction rate graph. From point zero to, more like to the quarter of the slope, you discover that the reaction is fast, So the curve is steepest at this particular region. Then you have the reaction slowing down from the middle, and then the reaction over, and then the curve becomes flat, at the tip edge. So concentration or volume, concentration of volume versus time graph. So the steep curve initially that's fast reaction. Curve levels off, the reaction slows as the reactants are, are consumed, and it becomes steeper as the steeper the slope, the faster the rate. So that's that for that. So sample graph interpretation. Reaction between magnesium and HCl. That's an example that I want to look at. So let's look at this. Okay. Oh, sample of graph interpretation. So we'll look at these and then we see magnesium and HCl. You can see the blue represents the volume of hydrogen and then the red concentration um of the acid, you know. So when we have that volume of hydrogen gas produced over time, so volume of hydrogen gas produced over time, then initial fast, then slows, eventually stops when Mg is completely used up, as we can see from our graph. So a practical example of reaction rate control. We use them in food preservation, lowering temperature slows microbial reaction. Industrial processes using catalysts to maximize yield, e.g. ion catalyst and Haber process for ammonia. So, and then explosion control, limiting oxygen supply, you know. So, okay. So that's that. And understanding reaction rate is vital in industries, healthcare, food preservation, and safety. Okay. Real life application of reaction rate curve. So So some of the real life application of reaction rates, number one, refrigeration, a slow spoilage reaction, catalytic converter, speed up breakdown of pollutants in car, fire safety, removing heat or reactants to slow combustion, then medicine, control drug release using reaction rate principle. Rate control is critical for modern technology and safety. So we see the application cutting across different fields and different strata of life. Okay. So let me summarize by saying that rate of reaction equals to how fast reactants are converted to product. Depends on factors like concentration. So it depends on factors like concentration, temperature, surface area, catalyst, and pressure. And then we try to explain collision theory and activation energy. We also look at graphs, we said graphs are useful for visualizing reaction progress. And then we have look real life application to show the importance of controlling reaction reaction rate. So these are some of the things that we touched on in the course of the lesson. So let's evaluate and ask this question. Which factors, please, if you have any question or area that you want clarity, please put them in the comment section so that I can respond to it, accordingly. So this question says that which factors does not affect rate? Which factors does not affect rate? The options are listed there. So tell me the factors that does not affect rates. And okay, so what does a catalyst do? We've talked about this before. So look at all the options. Does it speed up reaction by increasing temperature, increase activation energy, slow down an energy? So we said, what does a catalyst do? Does it speed up reaction by increasing temperature, increase activation energy, slow down a reaction, lowers activation energy in the name of Jesus? Sorry, please. I said, so what does a catalyst do? It speed up reaction by increasing temperature, increase activation energy, slow down a reaction, lowers activation energy. Which method is best for measuring gas rates? Is it ruler, pH probes, gas cylinder, or thermometer? In collision theory, what increases successful collision? So please let me know what your answer is in the comment section, and then I would let you know if you're correct or if you're wrong. So with that, we've come to the end of this particular lesson, and I want to say a big thank you to you for joining in and for participating also during the course of the class. So we'll continue from here in our next video. So stay tuned, and I'll see you in the next video.